Hi everyone, good afternoon. I'll start in 2 minutes more. Just give me 2 more minutes and we'll begin. Right, so let's begin now. This was the last question that I had given in the test session 3. This was the last question that I actually gave you all to do as homework the other day. And I'm not sure if you guys have done this yet or you have to do it. I'll be giving you all a few minutes to come up with the answer for this particular question. And just let me start the timer for you all. Probably 60 seconds would be more than enough. Otherwise, yeah, you could have taken maybe 120 seconds, but I'll be giving 60 seconds. The reason is because this was already covered in test prep 3. I have told you that you could have done this. You should have done this as a homework. So I'll just be giving 60 seconds. Again, if you haven't done this, please try to solve it. I've started the timer. Come up with the correct option. The options are given over here. The question was a bit long, so that's why I needed to put the options on the right side. Thirty more seconds, everyone. Please comment down your answers in the chat. $15 more seconds. So this question is a very interesting question. A lot of people would mark the answer as the wrong one, which is A, if you're thinking that the answer is A, and there is a lot of nuances in between that are given which actually don't make much sense, right? So first thing is there are a lot of stuff given in between that does not make much sense. And second point is that this question is a bit tricky because of how the filter object acts like. It's a very simple question if I would have put list of filter and the answer would have been A. But because I have not converted my filter object into a list, the filter object acts differently and the answer that I get is D, that is original high value dictionary, becomes nil. It becomes nothing. So this is the reason why it kind of, acts differently compared to the other particular, basically compared to the normal filter object, basically compared to normal list or a normal dictionary object, compared to how the filter object works. So now let me explain you. We'll not just go into the higher above this. Let's first see the correct answer is D, right? Now I'll explain you how do we come to this. We'll deep dive into it, right? Not just touching it from just the sake of touching it, but we'll go deeper into it so that you understand, right? Okay. All right. So let me just clear this 1 second. Let me just clear the screen. Okay. So as we can see, this is nothing but a list. And inside the list, we have dictionaries. So we have a list of dictionaries. Inside these dictionaries, what do we have? We have the product ID, category of the product, right? And the price of the product. And there are 5 such dictionaries in our list. So length of our list is nothing but 5. Now coming to the second one, which is saying that high value products equal to filter lambda P, 1 second, just give me 1 second, yeah. So basically what you're saying is that now you're applying a lambda function that will basically help you filter. So this lambda function will either return a Boolean value true or a Boolean value false. As we can see, it has one single inequality, but this will return only true or false. So wherever it returns true, that particular value, that particular dictionary in our case will be returned, otherwise it will not be returned. So how it works is this products, which is my list, on each of the object, the lambda will return a true, false, true, false, true, false. So basically either of the two. Now that it is returning either of the two, whether true or whether false, the filter function will say that I will pick only those wherever I have true. I will pick up only those indices or those index where I have the value as true. And where am I getting these true and false from? From lambda. So basically P is one individual dictionary. So lambda P means for every object in that list or maybe dictionary, in our case it is list, right? So let's just talk about list. For every object in that list, which is dictionary, for each dictionary in our list, assign it value P. So this becomes P. Check for P price. So basically the key, which is price, the P price, is it greater than 100? If it is greater than 100, return true, otherwise return false. So here I will get a true value. Now for the next one, it will move, the P will move to here. It will check whether the price is greater than 100. No, it will return false. Then it will move till here. It will say whether the price is greater than 100 and return true. Then it will move here, whether the price is greater than 100, it will return false. And again for this one as well, it will say whether the price is greater than 100 and it will return true. So my filter has basically will work on this particular true false and say that, okay, I will pick up only those indexes, only those indices that have true, that have a condition that returns true. Wherever it is true, I will keep that. And that is how your filter object will be created. Your filter object is not a list. It is an iterator. If you will print this high value products, you will get something like filter object. You will get what kind of or what type of this particular variable is, which is nothing but filter object. Inside what it is, you will not get anything. until and unless you convert it into a list. So you can say list, then filter, and then everything, whatever you have written over here. Then when you would have print this, then you would have got the first product ID, the dictionary of the first PID, or the product ID, the dictionary of the second product ID, the dictionary of the third product ID. But because you have not converted it into a list, it is just acting like an iterator. You can just iterate over it and pull some objects. Now this is how it becomes different, the filter object compared to an actual list. I'll soon help you understand when I come to this particular line of code. Okay. Now then they calculated some discount products. So in discounted products, it was basically doing what? It was saying that I want to create a new dictionary, and for that they are using map. So basically why they are using map? So they are saying for each of these PIDs or each of these product IDs that I have, I want to assign a discount and create a new price. I want to assign a discount and create a new price. So discounted price, P price into 0.9. So the discounted price will be, for this one will be 500 into 0.9, for this one will be 1200 into 0.9, for this one will be 100 into 0.9. And then your P will first be assigned to this. It will say, okay, I will take P001, and the price will be, for this particular thing, the discounted price, it will be, ID will be here, ID P001, then discounted price will be my 500 into 0.9. Then it will move to the next one. Again, it will say, okay, ID will be P003 and discounted price will be 1200 into 0.9. So basically the map is telling it that, hey, you have to do this operation. You have to do this operation on each of the items in your, or the objects in your list. You have to do this for each of them. So basically your Lambda is creating individual dictionaries, and map is telling that, hey, you need to do for all the dictionaries or all the objects in your high value products. So map is telling that don't just stop for one, you need to do this for all the objects in your high value products. In your high value products, you need to do for all of them. This is what it is saying. But again, as you can see, discounted products, we basically have not used anywhere so far. We have not used the discounted products anywhere so far. And hence I'm just over here. And you know that if high value products has P005, then discounted products will also have P005. The next will be ID P005, and then discount, and then 800 into 0.9, right? So this will have P005, right? Now why I'm only concerned about P005 is because I'm only searching for ID P005. If the ID P005 is true, I break, otherwise I take it as false. Initially, as I have assigned it as false. So I didn't have to do this entire step. I could care even less to do this entire step and save my time. I could have just said, okay, it's a simple map thing. It will create a map object, and inside that map, yes, because I'm iterating, I'm now iterating over here. Because I'm iterating, it's again, I will find the P005, and hence, because I'm finding P005, I will say that I will get a true over here. So this will become true. And hence false, this will never run. My P005, found P005 will convert to true, and that will be the variable that I will carry from this loop, and I will exit out of this. Loop. After I've exited out of this loop, and now again, this is a for else loop. So if you do not know what is a for else iteration, I've covered it in the test prep 3 or test prep 2. So you can go back and look over there, right? So now I've gotten that found P005 is equal to true. So my found P005 will be printed as true, is what I'm pretty sure of. Now moving to original high value dictionary. So now what exactly is original high value dictionary doing? So original high value dictionary is creating again a new dictionary from PID and price for all of the high value products. So basically what it is doing is for high value products, which are these three in a list, it is saying, okay, I will take the ID, then I will mark the ID as 001, then I will take the price, and I will mark the price as 00, whatever it is, 500. Then I will take ID, and after taking the ID, I will then mark it as whatever the ID is, basically whatever your ID will be. It will not actually, 1 second. So one thing I'm doing wrong over here is, 1 second, give me 1 second. Let me clear all the screen as well. I think it's too much on the screen now, right? Yeah. So basically in our high value products, I hope that it's clear that we have this particular PID, this particular PID, and this particular PID. This is what our high value products has, right? So basically we have 1 PID, 2 PID, 3 PID in a form of list, which are in a list. Now it is saying that you take the PID, so basically which is this PID, and then to it you mark a price which is 500. Similarly, we will get a second PID which is 003 because we are taking from high value products, and this will not go into high value products, so I'm ignoring this. So 003, and then we will take the price which is 1200. Then again we will take P0005 and we will take price which is 800. So this is the original high value dictionary, and this is the print command that will print true. So what I would get is, I would get found P005 true, and then original high value dictionary as maybe all three of these, which is not an option. There is no option out of these which do satisfy this. So I was thinking that A had option A probably had a true, but A does not have a true either. So it's completely wrong what I'm thinking of, right? I was telling you guys that you might come off with option A. So actually I don't even know what option you might have come with up after this. But now, then how was I saying that the D is the correct option? This will definitely print true. I'm pretty sure of that. This will definitely print true. But then how is it giving me an empty dictionary? Now again, going back to what I was telling you earlier, that filter and making a list after doing filtering are two different things. This is a filter object which acts like an iterator. This acts like an iterator. Once you have iterated, once you have consumed all the elements, either using a for loop or either using any other function, once you have printed or even let's say done some kind of calculation or stored these elements in somewhere, this object, let's say I said that okay, I will take the first element in my filter object. As soon as I take the first element, it is gone. Then I take the second element. As soon as I take the second element, it is gone. As soon as I take the third element, it is gone. And hence my filter object then becomes empty. That is the difference between a list and an iterator. My filter objects act like an iterator, and as soon as I consume the objects, they start automatically removing themselves from the iterator automatically starts removing themselves from itself. Now, because the filter object is acting like an iterator, it needs to be empty. It needs to be empty coming here. This particular object needs to be empty, right? This particular object needs to be empty. So where exactly does it get empty such that my original high value dictionary, because this is empty, it will be nothing but an empty dictionary, correct? I hope this point is clear. If my object or if my filter object high value product is empty, or my iterator, filter iterator is empty, then obviously I will get original high value dictionary as empty, right? And that is how the option is coming as D. But where exactly, at what point exactly am I consuming the elements in my object, in my iterator, in my filter object, which is acting like an iterator? I'm consuming them right here. And as soon as I have consumed them in my discounted products to create my discounted products map object, as soon as I have consumed them, my high value products, which is a filter object or an iterator, becomes empty. And because it is empty, there is no ID, there is no price, so you have nothing but an empty dictionary, and hence you are getting true from here, an empty dictionary from here. Now you could have avoided all of this. You could have avoided all of this. How could you have avoided all of this? You could have clearly just said that I'll take a list object over here. And as soon as you would have made this list, no matter how many times you pull the elements, no matter how many times you store it somewhere else, no matter how many times you make some calculations on top of them, it does not matter. The elements in a list will always stay there. Not like an iterator where the elements one fetched will themselves kill themselves or themselves destroyed. If you would have made this a list, your answer would be found P005 true, an original high value dictionary as this. This would have been the correct answer. But because you did not convert it into a list, your answer came out to be empty dictionary, because this object was empty, because this object, filter object, acts like an iterator. An iterator removes the element when they are consumed. An iterator removes the elements and only stores the current element where till where we have not retrieved or till where we have not fetched those elements from the iterator. It stores its state there and only stores the elements after that. So as soon as we have consumed all our elements from our iterator, from our filter object iterator, the filter object iterator high value product becomes empty or null. And as soon as it becomes empty or null, we will go forward and say that dictionary becomes empty. This is how we come to the dictionary that we will make basically becomes empty. So this is how the filter object acts like an iterator, whereas list is completely different from filter object. So very important point, that it's not very simple, it's not very intuitive. I understand that, right? A lot of you might not even know about it, might have not even heard about it. That's why we brought up this question. And it's not like something you would definitely read about on anywhere, right? So it's all right if you could not solve it, it's completely fine. But as long as you've understood this, I am pretty happy and I can go forward, right? If you have any doubts, please let me know. If you feel that you have a problem in this question, please let me know. Till then, I'll change to the second question. I'll answer the doubt. Meanwhile, whoever has a doubt can mention it in the chat and I'll come back. But for the others, let's move on to the next particular question, which is question number 2. So today I have brought 15 questions again, as in the previous session, right? Because I thought 1.5 hours is the optimum time for you guys to focus at one particular thing. And then you can go back and quickly revise all of these concepts that you've learned from these sessions, from these lectures, right? So 15 more questions we have today, right? And I want you to be with your pen and paper, solve all of those. This was a question that you should have done from the previous session that I have given you as a homework, right? You would have understood a lot of things while doing this on your own as well, right? If you didn't know filter and map, these filter and map become very important when it comes to placements, whether it is data analytics or whether it is data science. There are companies that directly ask you questions about filter and map. Companies like Swiggy, Zomato, Flipkart, InfoEdge, they directly ask you questions on filter and map. So you need to be good in filter, map, lambda, all of these advanced functions. Lambda functions are also called as anonymous functions because they don't have a name assigned to them. You don't assign def name of a function and then parentheses and build your function. Lambda function do not have a name to them. You can just assign a variable to them, and hence lambda functions are also called as anonymous functions. One fun fact as we go along. And now let's move forward to the second particular question. If you have any doubts, feel free to ask me. I hope it is clear that filter object is an iterator. Iterator destroys the element as soon as you fetches them. It removes the element as soon as you fetch them, right? It does not act like a list. If you want the filter object to be removed and you want it to be converted into a list, you convert it by saying list wrapper on top of the filter object that you have created. And that way you would have the entire dictionary over here as well as a true over here. All right. So now I'll be moving forward with the next particular question. I hope this particular question is clear. Let me just clear the screen for everyone. Now moving to the next question. All right. So good question. It's a SQL coding question. Generally, these kind of questions are asked. You will directly find SQL coding questions being asked in your online assessments. Sometimes even between MCQs, they will, you'll be surprised. You'll move to the next question and suddenly you will see a SQL question. Coding, what do you call that? A terminal kind of a thing would be there, and a code block would be there. You would be writing a code inside there, and that was just to give you a certain kind of that feel over here, right? Obviously, because we are starting live right now, I cannot provide a terminal for you guys to solve it. Hopefully someday I'll also be doing that for you guys, right? But not today. So I want you all to think and create a query on the basis of this question. I am giving you 120 seconds because It is a good question. I'm giving you 120 seconds to solve this particular question. Let me just start the timer. All right, please start it. And as mentioned, I know there might be other methods to solve this question from as well, but what I want you to do is strictly follow correlated subqueries. Now, if you do not know what correlated subquery is, try to solve it from any other method and put your answers in the chat. But if you know what correlated subquery is, try to solve this question strictly from a correlated subquery perspective. I have one more question today related to subquery and correlated subquery, and then I think, yeah, one more question after this. There are two questions in total. So I want you to go from this lecture and understand what are correlated subqueries and make your life easier by solving these complex questions where for each row you have a logic. For each and every row of your table you have a different logic or you have a different threshold. So I want you to take this correlated subquery from today's session or lecture. So that is why try to solve it. If you do not know correlated subquery from any other method, from maybe a join or a normal subquery, but if you know what correlated subquery is, if you are a student of my batch and you are here, I've already taught you correlated subquery. So please solve this question from a correlated subquery point of view. That will give you definitely an extra edge. Definitely will give you a better edge in interviews. You will look more learned that you just do not know uncorrelated subqueries but also correlated subqueries, and at the same time you will be able to solve it in a much more easier and a faster manner, right? All right. Let's see if you all coming up with an answer. Okay, I'll give you maybe 4 minutes for this. 2 minutes are too less. So I'll reset the timer and give you 2 more minutes. 2 minutes I felt a little less because it's a coding question. And these kind of questions are very common, guys. And I've seen a lot of students struggle with these kind of questions in interviews. Because definitely without correlated subqueries, it does become a bit overwhelming, like what to do, where should we start from? Should we take a join? How can I compare manager salary with the employer salary, right? So this is basically the employee ID, the ID of employee, the name of the employee, manager ID, who is the manager, right? Manager IDs and employer's ID will be same, so you can make a self join kind of a thing and solve it. That is one way you can do. You can create a self join and then create a filtering logic on top of that. One way you can do. Right, time is, there's still a bit of time left. Those who are not able to understand from a correlated subquery standpoint of view, try to solve this using a self join to get the manager and the manager salary next to each employee, and then simply create maybe a case statement kind of a thing, or I don't know, you can simply create a filtering where logic as well, anything that you feel is better. I'll give you 20 more seconds. Abhishek has answered. Select ID name from employee E1, join employee E2 on E1.id, E2.id, where E1.salary greater than E2.salary, right? All right, time is up. So now let's move on. So this is how you will solve this question based on using your subqueries. So this is how you can solve your questions using your subquery. So now let me explain you how this question can be solved using a correlated subquery. This question was definitely much more simpler if you would have done a self join, but not a lot of questions are much easier to solve using a self join, and the correlated subqueries makes it definitely easier, right? So over here I'll be explaining through correlated subquery. Then there is one more question where I'll want you to answer it yourself, to solve it yourself from what you have gained right now. And there I won't be explaining again what is correlated subquery, how it is different from uncorrelated subquery and everything. I will not go into the depth of it, right? So let's understand now. Okay. So the second question that will be of SQL, I want you to carefully look over here so that you can solve it on your own using correlated subqueries, right? Now, how can you solve this particular question is basically you understand that ID is the employee ID, manager ID is the employee's manager. So basically one means Alice is the manager of Bob, right? Alice is the manager of Bob. Then the salary, the employee salary, what is the salary of this particular person? What is the salary of Alice? Now what you need is write a query to find employees who earn more than their manager using a correlated subquery. So you want to write that, okay, does Bob earn more than Alice? Bob earns 80,000, Alice earns 90,000 in whatever units. It might be euros, it might be pounds, it might be INR, it might be anything, right? But what my concern is that whether Bob earns more salary than Alice, Alice being the manager and Bob being the employee. They all are employees. What I mean is like Bob is an employee, but Alice is the manager of Bob. So is Bob's salary greater than Alice? Similarly, is Carol's salary greater than its manager? Their manager is Alice again. So whether Carol's salary is greater than Alice. In this case, yes, it is greater than Alice's salary, right? So this should return Carol, but this should not return Bob, right? Then we have David. David has a manager, that is Bob. So is David's salary greater than Bob? No. Eve has manager, which is Bob. So is Eve's salary greater than Bob? No, right? So this is what you need to do. And in the end, you need to return only the employee IDs. And you can even return the name, anything is fine, whatever you have returned. Okay, that you can figure out by the sample output that will be given to you, right? What you need to return. So how will you do this? So let me explain you that how correlated subqueries and related subqueries are a bit different. So an uncorrelated subquery versus correlated subquery. An uncorrelated subquery runs only once for all the rows. Runs once for each row. So basically, if you have n rows, then the correlated subqueries will run n times. If you have n rows, then the uncorrelated subquery will run only once. So this is the major difference between uncorrelated and the correlated subquery. So correlated subquery helps establish a relationship between the outer query. It helps establish a relationship between the outer query and the inner query. Inner query in this is nothing but the correlated subquery. So it establishes a relationship, a row-wise relationship between the main outer query. This is the outer query, guys. This is the outer query. And the inner query. This is the inner query. Which is, inner query in our case is nothing but the correlated subquery. You can also call this as correlated subquery or inner query. Uncorrelated does not establish a relationship between the outer query and the inner query. You just run the inner query once. This will run once if it was uncorrelated. And then you will consume this value, whatever the value is returned for your outer query. Then you will consume it directly for your outer query. Nothing else. And that is how the uncorrelated subquery establishes no relationship between what the outer query is working on and what the inner query is doing. But correlated subquery will establish a relationship. It will establish a relationship between the outer and the inner query. It will say, okay, this is the outer query. Good. This is the inner query. Okay. Now for each row, for each EID, for each employee ID, I will run this once. For every employee ID. So for this, I will run it once. 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 For this, I will run it once again. I will run it once again. And that is how correlated subqueries are establishing a relationship, whereas uncorrelated subqueries are not establishing a very tight relationship between the outer and the inner query. Another important point to note is that whatever is the returned value from uncorrelated subquery is same for each row. And for correlated subquery is different, might be same as well, right? But is different or can be different for each row. If it was a correlated subquery, which actually it is, if it is a correlated subquery, and this yes is a correlated subquery, for ID, for this first EID, the correlated subquery will return something else. For the second EID, the correlated will return something else. For the third, it will return something else. For fourth, it will return something else. For fifth, it will return something else. But if it was an uncorrelated subquery, then for all of these employee IDs, there will be only one particular, whether it is one string, whether it is one value, whether it is set of records, they will be exactly the same. And what do you feel is required over here? In this particular case, because we need to check for each employee ID whether their salary is greater than their manager's salary. So for each employee ID, I will have to check from their manager's salary, right? Whether the employee salary is greater than their manager's salary. And when this employee is changing, the salary will change, and also the manager will change, and then the manager's salary will change as well. So for each row, my manager is changing, and hence manager's salary will change, and hence I cannot go with a uncorrelated subquery. It is much more easier for me to go and use a correlated subquery. So that for every employee ID, this manager salary changes. For every employee, the manager changes and the manager salary changes dynamically on the fly. And hence one more very important point is that uncorrelated subqueries are definitely faster and correlated subqueries are slower, because obviously they run every time for each row. They run only once, right? So I hope this is intuitive enough. Now let's jump into how we can solve this particular question using a correlated subquery. Let me clear the screen. So basically, in correlated subquery, again, you will use alias as you do in joins, right? So you will say, okay, I need employee ID. So select e.employee ID from my employees table, and I will give the alias as e, or I can even, using as is an optional, right? You can use as, you can remove the alias, up to you, but you have to mention basically you can remove the keyword for alias, but you have to definitely assign the alias, okay? You have to give it a new name. You do have to do that. So you've given the alias, right? So using as keyword is optional. You may or may not use that. Now you need to say that, okay, this employee ID will be that for which I need to apply filtering. This employee ID should be that in such a way that this employee salary is greater than their manager's salary. Now, how do I get the manager's salary is the only question. So I will create a subquery, a correlated subquery. I will say select managers.salary, m.salary from employees. Same table, right? Same table as m. So now I'm renaming the table as m, and I'm saying from this select m.salary, select manager's salary, right? Where now we know we want the manager for this particular employee. So we will say where E dot manager ID is equal to, now what? Now this particular manager ID will be mapped to this particular ID, m dot id. Now explaining you how I'm doing this is, let's say we are on this row, Bob. So my E dot id becomes 2. E dot id becomes 2. E dot salary becomes 80,000. Now I go into the subquery. I say select m dot salary from employer as m. So again I take this table, this time call it as m. Now where E dot manager ID, so here E dot manager ID is what? E dot manager ID is nothing but 1. So where E dot manager ID, so basically 1 is equal to m dot id. So m dot id is this. So this means 1. So I will select this particular row. And when I'm selecting this particular row, now what I need from it? I need only the salary. So select m dot salary, that is 90,000. So now it will look like select basically 2 from employees as E, where 80,000 is greater than my 90,000. This is not true, and hence you will not select it. You will move on. You will not output this. Then you will move on to this particular one. This particular one, third one. So you will say, okay, select. Now I've selecting the employee ID 3 from employee IZ. So where the salary is 95,000. Then you will go and see what is the manager ID. Manager ID is 1. So this particular table will return you what? M dot salary, which is for this ID. What is the salary? 90,000. So yes, this is greater than 90,000. This is true. So 3 will be outputted. You will get a record 3. And similarly, you will get other E dot ID. So this is how you can use a correlated subquery. Kind of a bit like joins if you're getting a feel of it, but not exactly like joins, because in join you first join all the entire data and then you perform the other steps. Here on the go, you are dynamically choosing which records to take, which records not to take. How that? By establishing a relationship between the outer query, E, you can see you're establishing a relationship between outer query and the inner query. E and M are the ones who are establishing the relationship. Right? So I hope this particular question is clear to all of you. Question will soon pop up again for correlated subqueries, and this time try to solve it from the correlated subqueries point of view. So if you solve using this in an interview, you will definitely get an edge over somebody else who's solving from a join perspective. Definitely you can solve this from joins as well, but obviously having an extra edge in interviews is beneficial. And this particular concept of correlated subqueries is very handy when you even work in industries going forward. Okay. Right, let me clear the screen now and we'll move on to the next particular question. Okay. Simple question. I'll give you 2 minutes, 120 seconds for this. Please start solving this particular question. If you have any doubts regarding the previous one, please feel free to ask me. Right, 1 more minute everyone, and a few seconds. Please come up with the answer. Very classical probability question, not very difficult if you understand independent and dependent events. I would rate this question as easy. Previous one was probably previous one was easy as well, or probably medium, not more than that. The first one was a tough question. That was a difficult question. This one is very easy. Please come up with an answer. These are basics of probability, everyone, and basics of probability are very, very important. If you want to become a good data analyst, a good data scientist, an AI engineer or anything, probability is the basic. This is 10th or 12th, okay, I think 12th class probability, 11th or 12th class probability. Going back to the school. Basics of probability are very, 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 very important. Time is up. I'm not seeing any answers so far, so I'm not sure if you have been able to solve it or not. You may take a few more seconds and answer it in the chat. Meanwhile, I'll start coming up with the solution. Right. So basically it says that two fair dice are present. One is having a red color. So let's just call this as red dice. And one is having a blue color. So let's just call this as a blue dice, right? So there are two dice. One is having a blue color and another is having a red color. And they're tossed independently. Let A be the event. So A is an event. So let's say A is an event. That the dice red shows 5 or 6. A is an event that red dice shows 5 or 6. B is the event that the sum of outcomes will be 7. So basically the sum of outcomes on R plus B is equal to 7. And C is an event that the sum of the outcomes, basically sum of outcomes on red plus blue die, will be 8. So these are the events. Then it's saying which statement is true. A and B are independent, A and C are independent, A and B are independent, A and C are not independent. And then there are multiple different things that are talking about whether these are independent or dependent. So before I dive deep into the solution, let's understand what are independent events and what are dependent events, right? A very, very basic but a very important concept. So two events, E1 and E2, they can be independent, they can be dependent, and mutually exclusive, mutually independent. Now, how two independents are independent means that if E1 occurs, then the probability of E2 occurring doesn't change, and vice versa. That means the events are independent. If E1 occurs, then probability of E2 might change. That means they become dependent events. They become dependent events in this case. So an event, two events are independent if one of them occurs and the other, the probability of the other occurring does not change. That makes them independent. And dependent events are those when E1 occurs or when any one of those events occurs, the probability of second event occurring changes, might increase, might reduce. Now two examples, tossing two coin and getting heads on both. So tossing two coin, or let's say getting heads on the second coin. Now if I toss a coin once, irrespective of whether I get head or tail, it doesn't matter. The second time I may get a head or tail is independent what I got in the first toss. It's not like कि पहले मैंने सिक्का उछाला, मेरा head आया, I get a heads, and then now I will get tails only. The probability has become 1. No, right? The probability is still 0.5 for heads or tails to occur. So tossing two coins becomes independent. Now let's say drawing an ace from pack of cards at second draw. So in this case, my first draw, when I make, the first draw that I make, if I get an ace, then the probability of drawing another ace, or basically this particular one, let's call this E2, the probability of drawing another ace will change. It will decrease because I've already taken out one ace. Right? But if let's say I do not get an ace, then because I've reduced one card, I've reduced from 52 to 51 cards, my aces are still 4. Here it will become 3 by 50, 51. My aces are still 4. The probability again changes and increases, making these two particular events as dependent events. Right? So this is the difference between independent and dependent events with an example. Now, how can we understand whether one event is independent or dependent? I don't know what I clicked on, 1 second. Yeah. So now what is the difference? Mathematically is as simple that for independent events, probability of A intersection B, basically event 1 and event 2 occurring simultaneously, or event 1 occurring and event 2 occurring, is nothing but PA multiplied by PB. But for dependent events, probability of A intersection B becomes PA multiplied by PB given A. That A has occurred. Now given that A has occurred, B is occurring. Now given that A has occurred, B is occurring, because we know the probability of B is not the same. PB is not the same as PB by A, as we saw in the dice example. PB was earlier actually 4 by 52 drawing A's, but because A came in, it would either become 3 by 51 or 4 by 51, and hence these two are not the same. Or you can also write PB that B occurred first, and then given that B occurred, A will occur. So conditional probability, either of the two you can take, they are same. Okay, they are same. Or depending upon what your problem statement is, you can take it better. So this is the only thing. If two events, if in our case A and B are independent, then we can just put this and check if they are independent. If this holds true, then yes, A and B will be independent. If this does not hold true, then that means they are dependent. So that is what we will do. As simple as that. It's a very important question, guys. I recently gave an interview, I think 6 to 7 months back at Flutter, and I had got this basic probability question over there as well, right? And I've seen this in many online assessments, many places. This kind of question be asked either in form of interview or either in terms of online assessment, wherever probability is actually valued, and there are many companies that value probability in statistics, right? Everybody values it, but in the context that they value it that much that they will actually, ask you questions on that, right? So that is what I mean. Okay, now let's move on and start solving the question. So event A is what? That having red color will show 5 or 6. That a red die has 5 or 6. So there are two outcomes, 5 or 6 for the red dice. And total outcomes for red dice are nothing but 6. So the probability becomes 2 by 6. Now B. For both red and blue dice, the outcome is 7. So I'll take red over here and blue over here, right? So how can I get 7? I can get 7 as 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, and 4, 3. These are the different ways I can get it. Yes or no, everyone? These are the different ways, right? Cool. All right. So now that I've got the different ways I can get it, what do I want to do with it now? To calculate probability, of course. So total outcomes obviously are 36, 6 raised to the power 2, tossing 2 dice, total outcomes are 36. And number of favorable outcomes is 1, 2, 3, 4, 5, and 6. That means 1 by 6. This means 1 by 3. Now, whether these two events are independent, I need to also find the probability of A intersection B. This is the probability of A. This is the probability of B. Now, let's find the probability of A intersection B. So, set A and set B, where do they have intersection? Wherever red is 5 or red is 6. So, red is 5 in this case, 6 in this case, sorry. Red is 5 in this case. So, only two outcomes is where they are intersecting. And those two outcomes are 6 and 1 and 5 and 2. So, out of these two outcomes, and there are total 36 outcomes again. So 2 by 36 will become my probability, which is 1 by 18. Now to establish independency, I will say whether PA into PB, whether it is equal or unequal to my PA intersection B. So this is 1 by 3 into 1 by 6, which is 1 upon 18, and this is also 1 upon 18, and hence equality holds. Therefore, A and B are independent. A and B are independent. This is correct. Now coming to A and C. Now moving on to A and C. Let me clear the screen. So A and B are independent. Let's just note it down. Now coming to A and C. So A we know 5, 6. The probability was 1 by, 2 by 6, which is 1 by 3. Now moving on to the second part, A and C. So the outcome is now 8. Now the outcome is 8. So let's write R and B. Now it will be 1 and, 1 will not suffice. So 2 and 6, 6 and 2, then 5 and 3, and then again 3 and 5, then 4 and 4 are the only ways we can get total as 6. Now in this case, what is the probability of our C? Probability of C, as we know, total outcomes are 36. So 1, 2, 3, 4, 5. So 5 upon 36. Now let's calculate A intersection C. So A intersection C is where we get red as 5 or 6. So one is this case and one is this particular case where red is 6 in the first one, in the second one where the red is 5. Therefore, 2 outcomes out of 36 is giving me probability of A intersection C, which becomes again 1 by 18. Now whether these two are equal, whether PA multiplied by PC is equal or not equal to PA intersection C will tell us whether these events are dependent or independent. So 1 by 3 into 5 by 36, if you solve this, it will not be equal to 1 by 18. This will not be equal to 1 by 18, and hence A and C are not independent. Therefore, the correct option is B, that A and B are independent, but A and C are not independent, or in other terms, they are dependent events. So the correct way to calculate PA intersection C should have been PA PC by A. Right? Not this particular case. Alright, so I hope this particular question is clear. Now I'm going to move to the next particular question. If you have any doubts, feel free to ask me, while the others can utilize that time solving the next question. Let me clear the screen, and also let me hide the brush. Right, moving to the next question, we can see the answer B is correct. Okay, question based on expected value. I think 120 seconds will be more than enough to solve this particular question as well. Let's see how many of you get the correct answer to this. This is a pretty simple question. No, actually, this one is not simple. This one is a good question, and it is actually a very, very important question. If you guys know about geometric distribution, you'll come to an answer very quickly. Otherwise, it's very difficult to come to an answer in this. This is based on probability distributions, discrete ones. Based on geometric distribution, a very, very important, a very good question. Nine more questions after this, as one last question will be for homework. All right, less than a minute. This was asked to so many people I have known, even to me, and so many people that I have come across with, some of them my own students. Inexperienced, experience with 1 or 2 years of experience. Seen this question being asked a lot of times. Let me tell you, this question, it's difficult to find the answer online as well. Even if you go and ask ChatGPT, it will tell you, it will just say that this is a collector problem and this is the formula. But the real essence is completely different. It's based on a geometric distribution problem, right? It's based on a geometric distribution problem. So I hope you completely understand it going forward. All right, time is up. Any answers, anyone? I hope however number of students are there today are actually solving it, not just, looking at the solutions and hoping that they would understand. If you don't think, those 2 minutes of time are for you to think. If you don't think in those 2 minutes, then your interview thinking capability as well as your test-based thinking capability. You're not developing it under time. And if you're not developing it under time, your initial thoughts are always scattered. Our initial thoughts are always scattered. So the time crunch is how fast we can actually gather those thoughts, streamline them, and come to a solution. And if you're not practicing time-based thinking, how to think better and structurally under time, your initial thoughts will always be scattered and you will not gather them in a less amount of time, right? So these 2 minutes are given to you to actually think. People who watch this after the live session is over, people who are watching it in the live session, I want all of you to utilize these 2 minutes and 3 minutes that I give to you to actually come to an answer, not just drink water or chit chat, use Instagram and social media. You can do all of that later, right? But these 2 minutes are for you to think and understand that your initial thoughts are scattered. How quickly can you jot those thoughts down? How quickly can you compile those thoughts and streamline them and at least come up with an answer, even if it is a wrong one, right? Okay, now let's solve the question number 4. So what exactly is this question saying? First of all, it's not written in a very easier term as well for you all to understand. So what it is saying is x is the number of, I'm sorry about it. Okay, the solution is 14.7. Doesn't matter because now we're already on the solution, so even if you saw it, right? Okay. So now x is the number of tosses of a dice. So if I toss a dice once, I will get x as 1. If I toss the dice 2 times, I will get x as 2. As simple as that. So the question is saying x is the random variable representing number of tosses of fair 6-sided die. This is what we have understood so far. Now let's understand more of it. What exactly is x? So x is until all 6 faces have appeared at least once. So basically when you toss a die, you will get 1. You might again get 2. So you have 1 and 2 both. You might toss it again but get a 1. You might toss it again and get a 2. You might toss it again, get a 3. So you've got 1, 2 and 3 now. You toss it again, you get a 1. You toss it again, you get a 3. You toss it again, you get a 4. So you now get 1, 3, 4. You toss it again, you get a 4. So we already got 1, 2, 3, 4. You toss it again, you get a 5. You toss it again, you get a 6. So how many total tosses did you take to actually get all these 6 faces of dice or all these 6 numbers on the dice? So you took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now this process is not constant, right? These 11 tosses will keep changing. Sometimes you may take 12, sometimes you may take 14, sometimes you may take 30, sometimes you may take 6, sometimes you may take 70. This number is not constant. But on a long run of it, you will, if you do it infinite times, if you do this infinite times and apply a limit infinite, x tends to infinity, where n tends to infinity, and all of the number of tosses from 1 till n, if you add them up, this will give you expected value. Add these number of tosses. So first will be 11 plus 12 plus 14 plus 30 plus 6 plus 70 plus something upon n. Limit n tends to infinity. This will go till infinity, e of x, right? This will get you the expected value. This is what you have to do. You have to tell me what are the average number of tosses you have to make to a die such that all the 6 faces at least appear once. So now this question is very, very simple. Let's understand how to solve it. If you have still not covered probability distribution, please take time to understand probability distributions. They're very, very important for data science folks as well as data analyst folks. Probability is the key, and distributions is a no-brainer. You have to do it no matter what, right? All right. So now let's first solve this question. So basically, I know that what I can do is I can say that when I toss a coin once, I will always get a new face. If I toss a coin, now how many times should I toss the coin to get a new face? Let's say I've already gotten 1. So this time my new faces will be 2, 3, 4 and 5. Then how many times should I to get another new face? Let's say this time I get 2. This time I get 2. So 3, 4 and 5 and 6. So out of this, let's say I get 3. So how many times should I toss it again to get a new face? Which is out of 4, 5 and 6. Let's say I get 4. So how many times should I toss it again to get a new face? Let's say this time 5 and 6 because 4 you've already got. So let's say we get 6. So how many times should I toss it to now get a face that is 5? And then add all of these and we will come to an answer. We will come to an answer. And this is actually nothing but the expected value of tosses to get new faces, expected value of tosses to get a new faces. And by adding all these expected values, I will tell, okay, expected value to get 1 new face, expected value to get 2 new faces, 3 new faces, 4 new faces, 5 new faces, all these 6 new faces. Adding them up will give me the expected values, expected number of times I have to toss a coin, or sorry, toss a dice, roll a dice to get at least all the faces once. Now I've understood that I can make this into different expected value problems. So that means this will be one distribution, this will have another distribution, this will have another distribution, this will have another, this will have another, this will have another distribution on its own. But what distribution will these have? If you have studied geometric distribution, or if it's okay if you have not, geometric distribution tells you the probability that you will get success at kth trial. It gives you the probability that you will get success at kth trial. So basically, one trial is tossing a coin once. Second trial is tossing a coin another time. In our case, one trial is tossing a coin or tossing a dice once. Second trial is again tossing a dice. Again tossing a dice. So what is the probability of success? And it says that probability that success will occur at kth trial, and these are nothing but the x is nothing but the number of trial that we are on right now. So the probability that the success will occur at kth trial is nothing but p, which is the probability of success, 1 minus p, which is the probability of failure, and k minus 1. And this is only applied to Bernoulli trials, by the way. This is only applied to Bernoulli trials. Geometric distribution only works on Bernoulli trials, right? So if you do not know about Bernoulli trials, you can definitely go and have a read on that, right? So these work only on Bernoulli trials. So in our case, what do we need is not what is the probability that success will occur at kth trial, but we need what is the average x. What is the average value of x? And each distribution has its expected value. And in our case, expected value for geometric distribution is 1 upon p. This tells us that the average number of trials you would have to make to get a success. These are the number of trials. Let's say if p is 0.5, then 10 by 5, which is 2 trials you have to make on an average to get a success. It might be 1 sometime, might be 5 sometimes, might be 2 sometimes, might be 1 many times, might be 2 many times, might be 3 sometimes, might be 4 other times. But on an average, you would need only 2 trials to get a success. And all of these are geometric distributions. This is a geometric distribution with probability of new face occurring. Because you have options of all the 6, because your options from 1 to 6, all of them, so probability of success is 1. Anything can come and the probability will be 1. Now over here, one face out of these might have occurred. So we have options only from 5 now, where total outcomes are 6. So probability of success becomes 5 by 6. Here, because 2 faces have occurred, so the probability of success for this distribution becomes 4 by 6. Here it becomes 3 by 6. Here it becomes 2 by 6. Here it becomes 1 by 6. This is geometric distribution with probability of success as 1. This is another geometric distribution with probability of success as 5 by 6. This is another geometric distribution with probability of success as 4 by 6. This is another with probability of success as 3 by 6. This is another with probability of success as 2 by 6. This is another with probability of success as 1 by 6. These all are separate geometric distributions. And what is the criteria of success? Getting a new phase. Getting a new phase. Getting a new phase given the previous phase has not occurred. Getting a new phase given the previous 2 phases have not occurred. Getting a new phase given the previous 3 phases have not occurred, and so on. That becomes your success criteria. Right? That becomes your criteria of success. Now, as simple as that, what do you need to do after this? You need to just calculate the expected value. So for this one, the expected value, for this one, let me just clear the screen now. So for probability 1, for probability 5 by 6, which this is nothing but 6 by 6, right? Probability 4 by 6, probability 3 by 6, probability 2 by 6, probability 1 by 6. For this expected value, which is 1 upon p, is nothing but 1. For this, it is 6 by 5, which is approximately, if you think, 60 divided by 5 will be 12, so 1.2. For this, it will be 6 by 4, which is 3 divided by 2, which is 1.5. For expected value for this would be what? Expected value for this would be nothing but 3 by 6, which is 2. For this, 6 by 3. 6 by 3, which is 2. For this, it will be 6 by 2, which is 3. For this, it will be 6 by 1, which is 6. So basically, on an average, getting a new face, you have to toss the coin only once. On an average, to get a new face, given the previous face has already, given that the new face is not the previous face, a new face apart from the previous face that you've got, the number of tosses you will need is 1.2. Now, the average number of tosses you will need to get a third new face is 1.5. The average number of tosses you need to make to get a fourth new face, apart from these 3 faces, whatever face, it might be 1 over here, 2 over here, 3 over here, it might be 5 over here, 6 over here, 4 over here, it might be 1, 7, 1, 3, 2, whatever it is, that does not matter. But a new face apart from the 3 previous faces, the number of tosses you would need to make is 2. Similarly, 3 and 6 for this. So the answer becomes 6 plus 3, 9, 10, 10 plus 2, 12, 12 plus 14, 14.7. Which is B, 14.7 is the correct answer. If you have any doubts, please let me know. This is a very good question, very interesting question. I hope it is clear to all of you, and I hope that it is but obvious now how important these distributions become, right? So now let's move on to the next particular question. If you have any doubts, feel free to ask me, right? Okay. Also, soon easier questions are also coming, guys. Easier questions are also on the way, right? Not everything is tough, obviously. Okay, this one is a slightly tougher question. I would count this as a hard question. I would give you 2 minutes to solve this particular question. If you have any doubts by then, please ask me. Very important question. Just gonna have a glass of water. This is based on soft margin classification in SVM. This is that function that we minimize in soft margin classifier of SVM. You may take time to think and come up with the answer. Forty more seconds. All right, time is nearly up. If you have any answers, you can please put it in the chat. This is a very rare question, very rare question that might be asked from you. But still, I've seen it. The team has seen it somewhere. That is the reason why we're putting it, right? Okay, so the correct answer is A. The correct answer is A. Now, let me explain you how. I won't go into much depth of first the SVM, then coming to hard margin or soft margin. I'll directly jump into soft margin classifier. You can go back and study about hard margin and all of that, right? Okay, so in this particular case, in soft margin SVM, this is the function that we minimize. Also, we have two constraints that for each data point ith, are y true for I and our weights multiplied by the inputs of I plus the bias of I, well, and the bias will also always be same independent of the data point, right? Weights and bias are independent of the data point, are greater than or equal to 1 minus, this is called as slack variable. This epsilon you see over here is called as a slack variable. And the second one is, so this slack variable also changes for each data point. The second one is that slack variable should always be greater than 0 or equal to 0. So these two are the constraints for soft margin SVM. Now what happens when C becomes 0? When C becomes 0, this particular thing goes to 0. Now the slack variable cannot be negative. This is true because this constraint still holds true. There is always a solution for W. Yes, you will get a solution for W for sure. This is true. And the solution for W will be actually, you will try to minimize this to 0. You will try to minimize this to 0. You will try to minimize this for 0. So yes, there is always a solution for W, which is true. All inequality constraints will be satisfied. There is nothing changing in this, and hence this will be satisfied. There is no C impacting the inequality constraints. These are the inequality constraints over here, and yes, this will be true. So hence A is false. Now how it is false? So basically, higher the C, higher penalty on misclassifications. Higher C, higher the penalty on misclassifications. That means higher the C, higher is the variance. Anyways, not even talking about variance and bias right now. So that means if my C is high, my data points will be less misclassified. And my decision boundary will be better. Higher the C, less the misclassification, better the decision boundary. But now C is 0. And when C is 0, that means that there is no errors on misclassifications. There will be maximum misclassifications, and hence decision boundary will be poor. Therefore, the resulting decision boundary can correctly separate all training points is incorrect. This is incorrect, and hence A is the correct answer. I wish I could have gone much more deeper into it. I wish I could go much more deeper into it. But obviously, because of time constraints, maybe sometime later, we might again come back to this C particular hyperparameter and we again jump into it in the upcoming session, right? But for now, I'll stop it here. If you have any doubts, please let me know. Till then, we'll move to the next question. Others who have doubts can let me know in the chat. All right. Okay, this is a very simple question. I will give you 1 minute or 60 seconds to solve this particular question. Let's see if you can come up with the answer. If you have gained anything so far, please make sure you're subscribed. It gives us the motivation, keeps driving us forward, right? So it will help us if you just subscribe and hit the subscribe button. If you're not yet, subscribe to us. Okay. So how can we solve this particular question? It's pretty simple. There are 5 options: A, B, C, D, and E. The caps one. Out of the given smaller statements, which all are correct? Okay, time is up. I hope to see answers in the chat. By the time I'll start explaining. So the correct option is D. So this actually covers your entire KNN if you look at it, right? This actually covers the entire KNN. So it's a pretty good way to cover entire KNN. Kudos to Data Avengers team for this particular question. And now let's start solving it. So which of the following statements are true about the k nearest neighbors algorithm? KNN is a non-parametric algorithm. Yes. Now what do you mean by non-parametric algorithm? An algorithm which has weights or which has parameters that it learns during training. That algorithm is called as parametric model or parametric algorithm. Hyperparameters and parameters are two different things, guys and girls out here. Hyperparameters are what you put to the model, what you give to the model. For example, in KNN, K is an hyperparameter. And distance, whether you will choose Euclidean, whether you will choose Jacobian or co-similarity or Minkowski or Hamming, these are hyperparameters. For example, in linear regression, what polynomial degree you will use is an hyperparameter. Or in case of regularization, what lambda will you use as an hyperparameter. But parameters, also called as learnable parameters, in case of KNN, there is nothing. You know that KNN does not have any parameters. It does not store any parameters. It simply goes, finds the k nearest neighbors in terms of distance and gives the answer. KNN does not have any parameters. Linear regression has parameters. All the coefficients, these are the coefficients. Basically, you might see them as beta 1, then whatever your bias is, right? Or your B in your basically mx plus c. So this is the coefficient, this is the bias. And all of these is basically, these are basically what the model learns during training. So linear regression is a parametric algorithm, but KNN is a non-parametric algorithm, and it can be used for both classification using majority voting and regression using either weighted average based on difference. I think we have already done one question on that. Weighted average based on distance in test prep session 1 or 2, or it can be done using simple averaging, right? So this one is correct. Now moving on to the next one. In KNN, the choice of k determines the number of nearest neighbors to consider for making predictions. Yes, pretty simple. K is the number of nearest neighbors that we choose to make predictions, and yes, this is correct. KNN requires a distance metric to measure the similarity between data points. Completely correct. KNN does require a measure of distance because it uses distance to measure the similarity. It can be a Euclidean, it can be Minkowski, it can be Hamming, it can be Jacobian, it can be cosine similarity, anything, up to you, whatever required data is. Now, D part. KNN is computationally efficient for large data sets. Completely wrong. And due to its incremental learning capability, no. First of all, KNN has no incremental learning capability at all. It has incremental time complexity. It has incremental time complexity. For every data point, you would have to calculate, n distances. For every test data point, and if there are n training data points, for each and every test data point, ON is the time complexity. So for larger data set, where m is greater than n, the time will be m. And hence there is no incremental learning, there is only incremental time complexity. And because it is increasing linearly, it is not at all efficient for larger data sets. It is not at all efficient for larger data sets. And hence D is completely wrong. KNN is sensitive to choice of distance metric, completely sensitive. Completely sensitive. There is one question that I will be covering about distance metric today. So you'll see why it is sensitive to distance metric. Value of K, of course, we have covered in previous test sessions. Increasing K increases the bias, decreases K increases the variance. So A, B, and C are the correct answers. A, B, C, and D are the correct answers. Okay, if you have any doubts, please let me know. Otherwise, I'm gonna move. Anyways, I'm gonna move. If you have any doubts, please mention in the chat and I'll try to solve it. Okay, one more question on KNN. We were talking about bias and variance and we got a question. 60 seconds for this. Please solve it, everyone. Pretty interesting question, a pretty simple one as well. Folks in the chat, please try to answer questions. Even if it is wrong, doesn't matter, right? We all are here to learn and grow. All right, what is the answer for this? 3 figures, 3 different KNNs, decision boundaries are given. Can you find out for which K is least and for which K is maximum? Basically the order of K. All right, we are halfway through the session. 7 more questions after this. 7 more interesting questions. Stay tuned. Complete it so that you don't have to later go and watch this again. You take a few things out of this session. You go back and you feel more confident. Okay, now I learned this. Wow, you get that kind of a feeling. All right. Okay, time is up. I hope to see answers in the chat. Meanwhile, I'll start explaining to all of you. Where is my cursor? All right, so 1 second, sorry, let me just clear the screen. So the correct answer is that K is least for the first, for the second it is moderate, and third it is highest. So how, basically, let's quickly understand. It's a very, very simple question. So first of all, high variance. High variance means more the model can learn. High variance means model can learn even more. And that leads to decision boundaries being complex. So more the variance, higher the variance, more complex the decision boundaries. So in this case, as you can see, the decision boundary is like this. In this case, the decision boundary is like this. In this case, the decision boundary is even more smooth. So I understand that decision boundary for this is more complex compared to this, Therefore, variance for this is much more compared to the second, compared to the third. Now, let's talk in terms of K. If I take K as infinity, I explained in my previous test sessions that if I take K as infinity, then, or basically K as n, which is the number of training data points, not as infinity. Better one would be to take as number of training points. If in your training points there were 100 cats and 200 dogs, or 100 fraud cases and 200 not fraud cases, your answer will be always not fraud cases or always dogs. Whatever, 2 very weird examples. But yeah, it will be either dogs or it will be either not fraud cases. So that means you are making an assumption that no matter what test data point comes in, the answer will always be the class which is present in highest. So increasing the K means you're increasing the bias, your assumptions are increasing. And hence, K decreasing means bias is decreasing. Therefore, K decreasing means variance is increasing because of variance trade-off. Bias and variance trade-off. Therefore, I will make now different signs because variance and decision boundary were proportional, but K and variance are inversely proportional. kind of inversely proportional, not exactly. There might be other things as well putting into it, but just to explain, right? So that means if variance for 1 is high, the number of nearest neighbors or k is least, this is moderate, and this is highest. This has variance which is lowest. Lowest variance means highest bias, and hence k3 is maximum. Therefore k3, k2, and then k1. k3 has, the third image has your lowest variance, highest bias. Highest bias means highest number of nearest neighbors. This one has moderate variance, moderate bias, that is moderate number of k neighbors. This has lowest variance, this is highest variance. Highest variance means lowest bias, and lowest bias means small number of k. Therefore A is the correct answer. All right, now moving on everyone from this particular question. If you have any doubts, please let me know. We're halfway through, I can say that now. Okay, Python it is. Simple question. We have done like this in the past, kind of like a revision question. Can you come up with an answer for this particular question, folks? Keep up the energy high. It's all right if you get wrong answers, doesn't matter. You are learning. At least you're learning. A lot of people who are probably not here might not know about these stuff. They're missing on it. At least you're here and learning all of these things. A lot of folks ask me about where they can find these questions. We have our own test series where we have all of these questions. Some of these questions are picked from there. Some of them I picked from my course. But a majority of these questions, a lot of questions, we have approximately 90 tests. There are 3 plans, the highest one being 90 and the lowest one will be being 40. So we have 40 to 90 tests covering all these questions and even more, from basic to advanced. If you're interested, you can reach out to me later. At the end, I will also put the link for the test series. And the test series is not very costly. 1,000 rupees for the basic one, 1,100 rupees, 1,100 rupees for the basic one, and 2,000 for the 90 tests, right? It's pretty cheap as well. And it covers aptitude, technical, everything, deep learning, Python, SQL, aptitude I don't teach much here, right? So probability, statistics, SQL, Python, deep learning, NLP, aptitude, Power BI, Excel, everything is covered in all of those tests, along with 20 tests which comprises only of previous year company questions. Previous year companies, like a lot of companies for data science and data analytics, like, right? All those companies, we have question bank for those, right? Okay, now let's solve this particular question. What will be the output of the following in Python 3? Pretty simple question, I feel. Is just how the global is just about the global and the local scope, and how is it different for mutable and immutable objects. So this is a mutable object. B is a list, index pointing to 1000. We print B0, we get 1000. Then we pass it into function over here. So our A becomes the same thing, B becomes the same thing. Yes, C is the correct answer. So A becomes B, B becomes same thing. Now C becomes again the same thing. This is how the variables behave. This is how the variables behave when they are mutable. I've taught this many times in previous sessions. Please go back and watch it if you haven't, right? So C becomes mutable. Now that this is mutable, when you are saying A0 plus equal to 51, you are saying, okay, take this index, add 51 to it. So you are adding 51 to it. So you add 151 over here. So all B, A, and C have this 51 now. You get out of the function, A and C, the state gets destroyed, B is still there. And now the answer is 1051. C is the correct answer. If you have any doubts, please let me know. How do they behave differently, mutable and immutable? You can go back and watch the test prep session 1 all of that is covered in that, right? Or a good revision question. I hope it is understood. If you are forgetting about it, go back and watch again the test prep session once. So the reason I'm not going again and again, because the things that I've already taught, I don't want to waste time teaching them again, because you already have those things somewhere where you can go and easily look at. I've already taught them, so that way I can teach you many more things. If I will keep teaching on things that I've already taught, that way you will not be able to learn many more stuff, many more concepts, many more topics from me, and that I don't want. I want to provide you as many information as I can in this less amount of time, right? So whatever I've already covered, you can go back and watch it in the previous sessions. Okay. Moving on to the 9th question. Okay, C is the correct answer, as we can see. Okay, pretty simple question. If you know about distances in KNN, this is what the question I was talking about earlier, that we'll cover one distance-based question as well, how it makes it sensitive. You have a few seconds, please come up with the correct answer. You ask text-based data, what kind of distance will you use when it comes to KNN? All right, after this, 5 more questions, everyone, 10 to 14. Then you all are free to go and practice as much as you can. Make the best out of it. Also, there will be one homework question that I would want you to do. 5 more seconds. I hope to see the answers coming in the chat now. All right. So here we go. Let me solve this. So which of the following distance metric is most appropriate for text data in KNN? So we are talking about text-based data when it comes to KNN. So obviously we are talking about stuff like, you're talking about basically text data. For example, words like hi, for example, words like data, for example, words like data Avengers, right? For example, words like maybe Python, for example, words like ML. So how will you find a similarity between these texts or these words? How will you find those? The answer is cosine similarity. Now, what exactly is Euclidean distance? Euclidean distance is, I hope you all know. So x, distance between 2 points in this format, right? If there are more coordinates, let's say there is a z axis, so then z axis will be there. If there are more axes, then this way. This is the best decision, the best distance to choose when you want the similarity between points in terms of shortest distance between the 2 points in space. If you want the similarity in terms of shortest distance between 2 points in space, you go with Euclidean distance. Jacobian distance works on basically a list or a collection of items. So it says, okay, I have a set A, I have a set B, then Jacobian distance is number of items in A union B and number of items in A intersection B. So if two sets are more similar, then the Jacobian distance, the Jacobian similarity is maximum. So basically if set A and set B will be equal, then my Jacob distance will be equal to 1. So this kind of things you can use, maybe for example, object detection, maybe for example, when you have set-based data, when let's say you're working on medical data and there are n number of diagnoses, n number of treatments that have been performed on that particular person. So you want to find the closest person. So you can say that, okay, in this set, I have n treatments that have been performed. So I will find a set that has me closest to these n items. So in that case, you can use Jacob similarity. Okay. Now cosine similarity is basically the angle between 2 points in space, the cos of the angle. If you go to trigonometry, the cosine of the angle between 2 points in space. And for text-based data, the smaller the angle, more similar these words are because of word embeddings. These vectors are constructed in such a way, basically this text will become converted into a vector. into a vector, this will be converted into a vector, this will be converted into a vector. And for example, let's say there are queen and king. So queen and king, because both are royal, right? Queen and king are nothing but the gender is different. Everything apart from that is same, right? So queen and king will have an angle which is less, right? If I take a boy, now boy and king will be close because gender is same, but boy and queen will be far away. So greater the angle, less similar the two words are. Smaller the angle, more similar the two words are. And how is cosine similarity calculated? You take the dot product between two vectors and then divide by the magnitude of the vectors. You get between 0 and 1. Right? You get between 0 and 1. 1 means cos 0 and 90 cos 90 means 0. And that is what we are saying. If two vectors have a 90-degree angle, that means there is no similarity between them. If they are if they have 0 angle between them, then it's completely similar. 0 angle, completely similar. Perpendicular, not at all similar. And then cosine similarity is the answer. Minkowski distance is a generalized format or an extended format of our Euclidean distance. It's actually, I'll just write the formula for it. So Minkowski distance is actually nothing but you can calculate it as for all the coordinates, whatever they are, right? So xi, first data point for the ith coordinate, xi2, let's say you have k dimension data. So you have to do this for all the, you take a q over here and then you take a square root of q. Okay, you do this for all the dimensions for the two data points. For k dimensions, you calculate this becomes Minkowski distance. If you put q is equal to 2, you will get Euclidean distance, and hence sometimes it is also called as L2 norm. If you want Hamming distance, you can put L1 norm, and this is actually absolute value. You will get Hamming distance, which would be nothing but x1 minus x2 plus x3 minus y1 minus y2 plus z1 minus z2 and so on, right? So this is generalized format for all the Hamming, Euclidean distance and so on. You can use Minkowski distance. Okay, also it also creates a new hyperparameter. Apart from just distance, it creates a hyperparameter q, so you can use this q according to your own needs. If q is equal to 2, you're just saying use Euclidean distance. If q is equal to 1, you're saying just use Ricardian distance, but you can also take other q's as well. Okay, all right. So this particular question, the answer is C, which is cosine similarity. Let me just remove this. We can also see the answer. Yes, so C, cosine similarity is the correct answer. Now let's move forward. Okay, NumPy based question. I'm starting the timer now. So 5 more questions including this one. Everybody, please keep your focus. Look over here, leave the phones aside. All that can be done after 20 more minutes. Right, please make sure your focus is over here and you are solving these questions. You're making a note on what your topics are weak, what topics are good, making a note of all of that while going along. So the question is basically emphasizing on the difference between np.arrange and np.line space. An interesting question to understand the difference between the two. If you know line space and arrange, all of it, basically the syntax of all of it, how it works, the answers will come out easily. All right, time is nearly up, everyone. Give you a few more seconds. Okay, so let's move forward and understand. Where did my cursor go? Sorry. So A is the correct answer, and let me just clear the screen. Now let's solve it. So basically, what is np.arrange? np.arrange returns a NumPy array between start, stop and step. So it will start from this, then it will return start plus step, then it will return start plus 2 into step. This is what np.arrange returns. So let's say if you have 0 and 1 and 0.3, you will get 0, then you will add a step of 0.3, so second will be 0.3, then you will get 0.6, then you will get 0.9. Okay, so this is how your np.arrange works. This NumPy array you will get in return. Also, step is mandatory, start and stop are also mandatory, and stop is never included. Even if, let's say, you were taking a step of 0.2 in this you were taking a step of 0.2, so 0, 0.2, 0.4, 0.6, 0.8, but you would have stopped here. You will not include 1. 1 by default is the stop by default, or the 1 in our case, is not included. This is how np.arrange works, right? So np.arrange always includes the stop value. No, this is a wrong statement, and hence I can remove this option. Now, np.linspace includes the stop value by default. Correct. np.linspace includes the stop value by default. So this is correct. So now this is correct, and both of these can be correct, right? So what does np.linspace do? np.linspace tries to, so basically the syntax is start, stop, both are included. This is included, this is included. Here only start was included. Start and stop both are included, and this is number of elements you want in between, or number of equally spaced decimals or float values that you want in between. So what it does is, it says, okay, you want 4 values. You want 4 values between 0 and 1. Between 0 and 1. So I will put 0, I will put 1. Now I need to put 2 values in between such that all of these are equally spaced. So how can I do this? I can put 0.333, 0.666, and you can see all of them have a difference of 0.333. So it ensures that you get a number of, basically a num of elements in total. So if you have mentioned 4, you will get start, stop, and 2 in between, in such a way that all of them are equally spaced. So here you do not mention the step size. The step it calculates on its own. Here you specify the number of items you want in between. 0.2 will produce 6 points. I doubt it, because I did the same thing over here. 0 to 1, 0, 0.2, 0.4, 0.6, 0.8. I get 1, 2, 3, 4, and 5 points. I would have get 6 points if I would have said include stop, because by default stop is not included. So I will not get 1, and hence it gets only 5 points. Line space produces 5. This is correct. Line space will produce 5 because you mentioned 5 over here. So this is correct. So actually 4 should also be, 4 is wrong, sorry. 4 is wrong, right? Because only this part is correct, this part is wrong, not 6 points, right? So 4 is also wrong. Now, coming to the last part, np.linespace avoids floating point accumulation error. Yes, line space is used when you don't want Python to throw the floating point accumulation error. When your floats are increasing, Python might throw floating point accumulation error. And when you do not want them, it is better to generate using np.linespace compared to np.arrange. So 1, 3, and 5 are the correct answers, and hence question number 10 is option A is correct. If you have any doubts, please let me know. Otherwise, I'll move on to the next particular question. Anyways, I'm moving on to it. If you have any doubts, please let me know and I'll solve them. Okay, now comes the SQL query. Because you've already, okay, 2 minutes for this. Only 2 minutes, because we've already learned correlated subqueries. You need to solve this using correlated subquery. It's a pretty simple one. Solve this using correlated subquery. After this, we have only 3 more questions. Only 3 more questions. And I think 2 out of them are very simple. One more minute. Let's see if you can get to the answer, everyone. First think about the inner query, then the outer query. Only 3 questions after this. Stay tuned. Complete it and then go. Feel much more relaxed. Alright, time is up. Okay. Let me open the screen brush and explain you the answer. So what is the question saying is that some countries have population more than 3 times that of all their neighbors. So neighbors is all the countries in the same continent. So all the countries in the same continent, you have to take those. So let's say in our continent we have a few countries, right? We take all of them. China, Pakistan, Bangladesh, we take all of them, right? We see, okay, is our population 3 times greater than all of these? Or the maximum of these basically. Is our population 3 times greater than China? Is our population 3 times greater than Pakistan? Is it greater than 3 times greater than, Bangladesh? Is it greater than 3 times of Sri Lanka? If yes, then we print India. That is what we need to do. We print a country that is India. That's what we need to do. All right. So this is what we have to do. So how can we do it? First, let's make a simple outer query. We know that what we want to do is we'll select name of the country that we want to print. Let's say we also need continent. We might print it, we might not print it for right now. Let's say I'm just ignoring it. So let's select c1.name. So I've called this table as c1. Select c1.name from countries c1, countries as c1. I'm calling this table as c1, where c1.population is greater than 3 times of, now what do I need over here? For each country, I need the maximum population among the neighbors. I need the maximum population among the neighbors. And for each of C1 country, this will keep changing. And that means, as simple as that I need to use a correlated subquery. I need the maximum population dependent on my country C1, c1.name. Therefore, what I will say is create a subquery. I need max population, C2 dot population from countries. I'm again naming it as C2, from country C2. Now I need maximum population from country C2, but maximum population of what? Maximum population of its neighbors. So how do I filter out the neighbors? How do I filter out the neighbors is my next problem. So I will use a where, because I need to filter on the rows and not the groups. I will use where and say C2.continent is the continent of this table that I'm creating should be same as the continent of, for first row it should be same as Asia. I will use C1.continent. So for first row it will be Asia, for second row it will be Europe, for third row it will be Africa, right? And also neighbors, I don't want to include the same country, right? Why will I check India's population with India? We shouldn't, right? Why will I check China's population with China? We shouldn't, right? So I will have to also remove the same row, because otherwise I will never get this criteria. Let's say I have a country with 3 times more population, but because you're comparing it with that country itself, the same countries are being compared, so you will get nothing, right? You will get all false, empty. And hence you will say, and c1.name, as you can see, name is nothing but the country name, is not equal to c2.name, and this entire now becomes your correlated subquery or the inner query, and this becomes your outer query, and this is what you've done over here as well. Okay, if you have any doubts, please feel free to let me know. Otherwise, I'm going to move on to the next particular question, which is question number 12. Okay. Okay. This question has been asked in previous year company test. As far as I remember, it was either Ola or Uber, DS, or I think data analytics, not sure. This question was asked there. I'll give you 60 seconds to solve this particular question. All right, please solve it. All right. Okay, so time is nearly up. It's not a very simple question because it's a simple question, just the wording is not very easy. Okay. So first of all, we look at this image and understand what kind of clustering is this. So during a clustering experiment, we get something like this. This kind of look like nothing but k-means clustering. This is not DB scan. This is not hierarchical clustering. It looks like simple k-means clustering to me, right? So I've understood now whatever assumptions I'm going to talk about will be from a perspective of k-means clustering. They will be perspective from a k-means clustering. And so all these assumptions will also be from a perspective of k-means clustering. So in k-means clustering, variance of every feature is spherical. Yes, that is truth. Now, instead of variance, think about k-means clusters, how they are made. The clusters are spherical in shape. That means the spread of the features is spherical, the variance is spherical, and hence the assumption 1 is clear. It is correct. K-means always gives us spherical clusters, homogeneous clusters, unlike DB scan or any other clustering technique where we might get non-homogeneous clusters. For example, DB scan will give us these kind of clusters. K-means will always give us these two clusters, right? Not overlapping, sorry, these two clusters, right? So there definitely assumption or DB scan might give us one cluster like this, another cluster like this, right? One cluster like this, another like this, not spherical. But K-means clustering will give us spherical clusters, and hence assumption 1 is correct. All features are different priority. Now this one is wrong. This one is wrong because K-means clustering. Now what do we mean by different priority is that in K-means cluster we talk about distance, right? In K-means clustering we talk about distance. Where in K-means clustering we talk about distance, we know that if one feature has higher scale compared to other, one feature will be given much more priority compared to the other feature. And we don't want to do that. So as a go, we actually scale our features if they have basically higher, different scales. So even if they have different scales, we would do feature scaling. And if they don't have different scales, then obviously all of them have equal priority, right? All of them have equal priority. Therefore, all features are different priority is wrong. So this is out of the picture, right? This one is out of the picture. Now all the features have same variance. All the features have same variance. Again, just a different wording of what was written above. K-means assume that all the features have same variability, the same spread, because if not, then you are making it on the same scale, right? And because of doing that, assumption 3 is actually correct, just the opposite of assumption 2. So therefore 1, 3 are correct, hence this becomes wrong. Now coming to fourth, all the clusters have the same sum of squared. So theoretically, all the clusters actually have same sum of squared error, have the same, basically sum of squared error means nothing but within cluster variance, you ideally go towards that, but if not very same, then it is approximately equal. So yes, theoretically this assumption is also correct. Therefore 1, 3 and 4 are the correct answers, and question 12, C 1, 3 and 4 is the correct option that you should have selected. Okay. So basically these were a bit of assumptions about k-means clustering that you should be aware of. And just by changing the wordings, it became a bit difficult for you guys. If it would have been written k-means cluster makes spherical clusters, yes, all the features are given same priority. This was only easy. All the features has same are assumed to be similarly spread. Yes. Right. All the clusters have least sum of squared error. This one was a bit tough. I'm not very sure if you would have know about this assumption, but theoretically, yes, k-means clustering we try and we are targeting to move to that the sum of squared error is approximately same, if not exactly the same. So theoretically, yes, exactly the same is what you want. So 1, 3 and 4 are actually the correct ones over here. All right, now I'll move on to the next particular question. If you have any doubts, please feel free to let me know. Okay, this is a pretty simple question. I'll give you 60 seconds to solve it. One more question after this. That's based on ML, I think. And then a homework question. 2 more questions, 10 more minutes, everyone. This one is a very simple question. Just have to calculate the average value of the given data, removing the 15, multiple of 15. Very simple question. All right, time is up. Let's start solving it. I hope you will put the answers in the chat. Not pushing you guys now to put the answers in the chat because I understand that it becomes a bit tiring till the end, but this is what you guys need to work on. All the guys and girls out here, need to work on, right? Increase the focus. All right, so let x be a random variable. This should be capital X. X be a random variable having discrete uniform distribution. Okay, so it is a uniform distribution, means probability of this is same, 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 probability of this is same. So that means E of x equal to x into px plus x into px upon px plus px all become same. That means it will be just x into p of x. All the x will be added. P of x divided by n into p of x. This and this will be gone. Therefore, x upon n, which is nothing but the average is what you need to take. It is nothing but the average that you need to take. Sorry. This is not px. I did one mistake. 1 second. Sorry. Let me just clear the screen. Yeah. So expected value is nothing but, let's say, xi into probability of xi. Let's take 1 for now. 1 plus x2 into p of x2 plus x3 into p of x3. So what we know is x1 into number of x1 upon total plus x2 into number of x2 upon total, x3 into number of x3 upon total. Now all of them are same. That means if there are, as you can see, there are 1, 3, 5, 7, these are all odd numbers. These are all odd numbers, right? Because these are all odd numbers, there will be 50 terms. So all of them are same. That means 1 by 50 plus x2 into 1 by 50 plus x3 into 1 by 50, which is nothing but as simple as that x1 plus x2 plus x3 till x50 divided by number of terms, that is 50. So you need to simply just calculate the average because it is a uniform distribution. Simply just calculate the average. You don't have to worry about the weighted average or anything because in uniform distribution, each of the items have same probability, right? Okay, now that you've understood that you need to calculate the nothing but average, what average do you need to calculate? So you need to calculate where x is not a multiple of 15. So we know we have odd numbers here, 1, 3, 5, 7, then you will have 9 till 99. So you have 50 terms. So what do you need to calculate? Sum of these minus sum of 15, multiples of 15, x multiple of 15 in this, and divide them by 50. So how you can do this? Simple, it's an arithmetic progression. The average of an arithmetic progression is nothing but 99, the last term plus the first term divided by 2. This will give me the average. Average is nothing but 50. Now, if average is 50, then total sum is what? You know, it's simple, right? Average is equal to sum of all divided by number, right? So if average is 50, terms are 50, then sum is what? 2500. So sum of all is 2500. Sum of all the terms is 2500 divided by 50 minus sum of x, which are multiples of 15. So multiples of 15 will be 15, then you will have 30, then you will have 45, correct? Then you will have 60, then you will have, I think, 75, and then you will have 90. But because we have only odd numbers here, so 30 is gone, 60 is gone, 90 is gone. So we have 15 plus 45 plus 75, so which is 135. So this becomes 2365 divided by 50, which is the A option. Let us just check it. Let us also check it once. So you can see question number 13, A option, 2365 divided by 47. Oh, sorry. Also we removed, one second. I did a blunder. So also because we removed 3 terms, so 3 terms will be subtracted from this. So we get 2365 divided by 47. Right, I forgot to remove the terms from here. Don't do such silly mistakes like me. Thank you. All right, so this will be the answer. Okay, now moving on to the next particular question. This was simply a aptitude question, right, written in terms of probability. All right, 60 seconds for the last question. Everybody, please put in your answers. This is the last question. I will be also giving you one homework question after this. Alright, if you're still here and you haven't like subscribed, please do that. It keeps the team motivated. Thanks a lot. Time is up. I'm giving you a few more seconds. Just give me 1 second, guys. I need to also send you the slides, right? So I'm just copying the link of that. 1 second, everyone. Okay. So these are the slide link. You can refer to them. I'll soon make them public, right? But keep it handy with you. All right. So now solving this particular question. So which of the following ensemble methods, when applied to the same dataset, generally leads to lowest model variance? Now the answer for this, a lot of people might put as bagging or boosting. But the correct answer is random forest. I've seen a lot of people mention bagging and boosting as the answer, right? But the correct answer is random forest. Now how random forest? What does bagging do? Bagging combines or basically aggregates the output of weak learners. And because we are averaging out the outputs, the access, I'll give the access very soon, right? Just after I finish this. So after the aggregation is complete, or basically after we've averaged out the outputs of models, we are actually doing what? We are actually reducing the variance. So yes, bagging does reduce variance. Boosting is not intended to reduce variance. Boosting might make, because we are actually now putting everything in sequential, also giving more emphasis on the error terms, we might increase variance. So boosting is not the correct answer. It might be bagging. Bootstrapping means that out of the data that you have for particular step of model training, let's say for this particular split, you select only a few particular rows and use. You do not send this particular row. For the next particular split, or let's say next particular gradient boosting step, gradient boosting or gradient descent algorithm step, you select different rows and use them for the split or for training. So bootstrapping refers to picking up sample of with replacement, picking up sample of rows out of your entire training data. So that is bootstrapping. It does not reduce the bias or variance. It does not affect the bias or variance. So the correct answer to this is actually random forest. This is also not the correct answer. Now random forest we know has bagging. So yes, it reduces the variance. But also random forest uses bootstrapping, which does not affect the variance. Just giving for information. But random forest uses random feature selection. At each split, it sends only 3 features or k number of features, which is generally divided by 3 basically. This might change as well depending upon what you are using, right? So total features, only 1/3 of features, it randomly selects and sends it at a split inside a tree and across all trees. This makes sure that your one tree is different from other. Because if same features were sent to this, same features were sent to this, these two trees will be nearly identical. And if they are identical, they are highly correlated. So if this makes an error, this will also make an error. If this learned some noise and makes an error, this learned the same noise and make the error. But by choosing different features, I am getting 2 trees that are completely different, that are completely uncorrelated. So where this is making an error due to noise, this might not make an error. And because of hence bagging and feature selection which reduces the error by reducing the correlation, it reduces the correlation between each tree. By these 2, random forest is the one which actually leads to the lowest model variance out of all of them. So the correct answer is D, random forest. Let's also quickly have a look at it. So yes, random forest is the right answer. If you have any doubts, feel free to ask me in the chat about it. Now moving on to question number 15. This is a question I want you to do as a homework. And in the next test prep session, we'll begin with this particular question. Feel free to ask me if you have any doubts. If you have any doubts, feel free to ask me. Okay. All right. And thank you all. Have a fabulous day ahead and a good weekend ahead. I'll see you in the next coming weekend. If you have not subscribed, if you've gotten anything out of this, make sure to click that button. Like as well if you can. Probably would just take 1 second, but might help us. Never know, right? So we will see each other upcoming week. And till then, keep practicing. All the best. See you all. Have a good day.